Good morning, friends. So, in today's course, what we are going to do is we are going to take a new topic on cognitive psychology, which is called problem solving. And so, problem solving is like the culmination point of any cognitive process. Now, when I say this problem solving is the culminating point of any cognitive process, what do I mean by that? Now, it is that process which comes right after something is encoded, something is perceived, something is being attended to, and then a problem is generated. Look at any problem in this world. Look at the problem of perception, or looking at a tree, or looking at a visual world around you. Now, the process starts by looking at the distal stimulus, then forming the proximal stimulus, then forming a percept out of it, which is the process of perception. This percept is then basically given attention, which is the process of attention, a sustained attention, and through it certain characteristics of the percept are processed. After that, next process comes in is basically called storing this material that you or storing this visual information, which is in terms of mental representation of the visual nature, making or storing this representation into first in the short term memory and then storing it to long term memory. Now, once that gets stored into long term memory, it is then analyzed, and the analysis of this percept for generating meaning is basically problem solving. Basically, what you have seen, or as I described this process, in the mental representation of what you saw as a distal stimulus, the meaning part of it, the analysis part of it is called problem solving. And so, looking at something in the environment is the start of the cognitive process, and the point at which you need to decide, or before deciding, the point at which you ask this question of what is it that I am looking at is called problem solving. And so, basically what is the problem here? The problem here is what are you looking at. Now, problems are everywhere. If you look around, anything that you do, any cognitive process raises a problem, and so it is the next to last step in problem solving. And that is why the three sections of problem solving, decision making and reasoning are called the higher cognitive functions. Why they are called the higher cognitive functions? Because these processes actually make you do the interpretation of the stimuli. Up till now, whatever we have looked at in terms of perception, memory, attention, and categorization and language, all these processes were required to take in information from the environment and then encode it or form mental representations of it. The process of problem solving, a process of decision making and the process of reasoning are the three processes which actually help us in making interpretations of things, making interpretations of what the visual stimulus is, or whatever problem is being put on to the cognitive system. So, then let us look at the first slide which I have over here, and so these presents some basic problems in life. And so, what you see here are natural problems, and I will also explain to you a natural problem of what a problem is in a few minutes. So, in the first slide, as you see, the fish has a problem of having a problem with the fish food which is outside its box, and so the problem solving technique that it is using is basically it perceives that it needs food, represents this mental representation that the food is realizes the food is outside the place in which the fish is, the aquarium in which the fish is, and so decides to use this kind of hanger to get the food. Similarly, there are other funny problems. For example, the one you see in the extreme right top is the idea of solving a problem, and so we generally use this idea of thinking outside this box, and so this person has now come out of the box at the literal, the metaphorical box that I am talking about, and so he has come out of the room from where the problem is. Now, he does not know how to get in, and so that is the problem for him, right. So, he thought that he should think outside the box, and so he came out of it. And in the last one and or the bottom slides, you see this cat having this problem of food which is in this particular box, and so what the cat decides is to use this kind of a problem solving technique. Although the easiest technique would be to hit this bottle and get it out, but the cat decides to go on and do this. So, basically through these funny pictures I am demonstrating what a problem is. And so, in your life also, in your experience, everyday day to day experiences, you have a lot of problems. And so, one of these problems could be taking an exam, or it could be to do your academic work. And so, when one of the things that happens in academics is writing a paper or writing a dissertation, and so that could be also a problem. So, this kind of a thing, the writing a dissertation requires certain kind of input or certain kind of processes which you should go through to solve this problem. And this idea of how do we solve of writing a problem, how do we solve this problem of writing a dissertation or basically a paper for some course, that is a that could be considered as a problem. And so, solution to this lies in identifying something called the initial state, which is the state at which you identify that what is the problem, identifying something called the goal state, which is the state or which is the point at which you have written the paper, and certain rules and certain hindrances to it. So, certain rules of what you should do and what you should not do, and basically hindrances in terms of what can be done or what are the problems in your field. So, taking the idea of a problem of writing a paper for your academic course, this problem has an initial state where you are worrying about writing this paper, or we are thinking about writing this paper, and this is the initial state. The goal state is that state where you have finished your paper and you are happy, or you have got a B or a C or whatever into that paper, maybe an A. I do not know, depending on your intellect, you would get any letter grades out of it. So, that is the goal state where you have finally successfully written the paper. And then there are certain rules. The rules are that you have to follow certain sections, certain kind of knowledge, and or certain kind of strict adherence to. For example, you cannot copy things from the internet. You have to think about a genuine problem, use certain ways, certain if it is arithmetic problems, use certain kind of an arithmetic rule, or if it is a problem from psychology, use certain kind of knowledge from psychology which suggests what can happen and what cannot happen. And then basically certain kind of hindrances is the term of the fact that in maybe you are hungry at this point of time, and so that is an hindrance, or the fact that you have to go with your friends out today evening, and so you do not get time to write the paper. So, these are the hindrances, or hindrances could be a number of things. And so, basically then this is how the problem really works, or this is how the demonstration of a problem is. So, right. So, basically any problem will have these 4 parts, and so let us discuss this in detail. So, what is a problem then? What do we call a problem? Now, as I said, as I explained to you with an example of what a problem is, generally a problem consists of several basic elements. One, the first part of it is called the initial state. This is the situation at the beginning of a problem. So, this is the state, or this is the point at which a problem starts. Right. This is the state where this is the point where you realize that you have a problem, and this is the point when you start creating mental representations of the problem, or encoding the problem as such, or realizing that there is a problem, or you have come to a point, or you have in your life or in your cognitive process where something is creating hindrance, something is creating disturbances, and so now you need to solve it. So, the first state is realization that you have a disturbance, and this disturbance should be cleared out, and that is what the initial state is. Matching the initial state is a state which is called the goal state. Now, this is that state which you arrive after you have solved a problem, and so this is that point which will come to you once you have solved a problem, once you have acquired the solution to a problem, and then you become happy, you become elated, or whatever you do, whatever feeling you have once you solve the problem, that is called the goal state. And then there are two certain substates for a set of rules, as I said, constraints that must be followed. So, certain rules, for example, this what can be done and what cannot be done, what is allowed and what is not allowed to solve the problem, and a set of obstacles, for example, hindrances that has to be overcome. So, as I explained in the paper writing problem, the hunger that you are feeling, or the fact that you have to go with your friends today evening, all these things are called hindrances or set of obstacles which are out there. So, basically then a problem, definition of a problem has any problem has these 4 points onto it. Now, obviously, the question now comes in that what are the type of problems, how many types of problem can exist, and so there are 2 basic categorizations which are out there. We will just look at these 2 basic categorizations. The first categorization is the difference between a well defined and an ill defined problem. Now, what is a well defined problem? Well defined problems are those problems which are cleared and structured, and they have very clear and structured initial state, goal states and constraints, and all are understood for it. For example, a problem of writing a paper. Now, when you are thinking of writing a paper, it is a very clear problem. You know that there is an initial state, the worry that you are having, the final state where you want to reach, and you know all the hindrances which is out there, and so these are called well defined problems. So, those problems which present themselves in a very concise way, where you know where you start from and where you want to go, and you also are able to see the set of rules which you need to follow and the set of hindrances that you need to that you will face in the way, is called a well defined problem. For example, think of a problem of getting a license. Now, when you want to get a license, there are the initial state is you do not have a license, the final state is getting a driving license, and then there are certain rules. For example, certain rules have to be followed. You have to give a particular exam, a learning exam, and then after the learning test you have to give the full test, and in that you have to show the driving. So, you have to learn, and so on and so forth. And certain hindrances, the hindrances may be to study for the exam, to pass the first learning test, and then to pass the second learning test, to make enough number of practices, the fact that you do not own a car and then you want to learn car. So, basically then the fact that you have to go to someone who has a car and then get his permissions. So, these are the kind of hindrances which is out there, and so these are well defined problems. In addition to the well defined problems are ill defined problems. Now, what are these problems? These are fuzzy and abstract problems, that is the initial goal state and constraints have gaps in understanding, leading to difficulty in assessing the solution. Now, in this case what happens is, there is an initial state, there is a final state, but you do not know how to go from the initial state and the final state, or then you do not know how to what are the hindrances in it. For example, let us say that tomorrow I want to stand in an election and become a minister. Now, if this is the initial state, I do not know what the final state would be. Of course, becoming a minister is the final state, but I do not know how the process is, what are the hindrances, what are the steps to be taken, and how do you become a minister, or what is a minister, what kind of minister should I become, and all those questions are there. And then there are kind of rules that I have to follow. So, what are the rules of nominations, when they are there, on what basis my nomination can be rejected, how to stand for someone, how to impress people so that they vote for you, since it is a democracy, so people vote for you, and so many other things are there. So, I do not know on these intricacies, I do not know all these hindrances which are going to be there, and all the rules which are out there, and so this is an ill defined problem. For example, for a person like me who is an academician, to become a minister, there is a set of becoming a minister itself is a ill defined problem, or going to the moon is an undefined problem. So, I do not know how to go to the moon, right? Where should I apply and what should I do to go to the moon? So, this is an ill defined problem. Now, in addition to well defined and ill defined problem, there is another categorization out there which is in terms of routine and non-routine problem, and that is, routine problems are those which you are familiar with, the type of process that you have to follow, and non-routine problems are problems where you do not know what steps to follow. So, basically in terms of well defined and ill defined, you can also have a match between routine and non-routine problem. So, a routine problem is one that can be solved by applying well practiced procedures, right. For example, writing exam, making tea. So, in making tea you know what to do. So, start with boiling the water, put sugar into it, put milk into it, boil it for some time with tea leaves, and then you get a tea. So, this is a well defined problem where you know number of steps that is to be there, the kind of hindrances that is there, initial state where you have water and other materials, other raw materials from which tea is made, and a final state where you finally get that liquid which you call tea and enjoy it. And so, this is a routine problem. Opposed to this is basically a non-routine problem, something that you do not face every day. For example, let us say you have had an accident, and in this accident you have now got a twisted ankle. Now, this is not a everyday thing for you, and so this is a non-routine problem. So, how do you go ahead and treat this, or how do you go ahead and take precautions? And so, this is a non-routine problem because you do not take this every day, or the idea of writing a research paper, because that does not happen every day, you do not do it so on and so off and so often, and so your familiarity with this. So, twisting an ankle, treating a twisted ankle, or any other kind of problem which is not well defined, which does not happen too often for you, and so you are not familiar with the process, is called a non-routine problem. So, basically then two categorizations, one is in terms of well defined and ill defined problem, and the other in terms of what is a routine problem and non-routine problem. So, basically when this problem is present, there are certain ways to solve this problem. There are certain answers to solving this problem, but there are certain challenges out there which happens or which arise when you solve problems. There are certain challenges which is out there. For example, problem solving is the last hurdle to most cognitive process that I have been saying all along, and it takes a long time to accomplish. Up till now, you have seen those processes, cognitive processes, which help you into encode information, make mental representations, realize that some information is there, store it, and then basically that is the end of it, right. Understand in which format is appearing and store it in some format, and so on and so forth. This is the step. Problem solving is the step where you realize what the problem is, or realize what is to be done with whatever has been stored and what is to be generated out of it, right. So, that is the problem solving position, and so solving problem does take more time. It takes more time because you have to realize where you are and where you want to go. Right. If you have a problem, you should know where you want to go. If you don't know where you want to go, then it is not a problem solving technique, or this is not problem solving. So, you always know where you want to go or what is the goal state in a problem. So, assessing problem solving in terms of accuracy rate provides a rather gross estimate of problem solving proficiency. Now, why am I saying that accuracy is not a good idea? Accuracy does not demonstrate how do you solve a problem. Now, a person could be very familiar with a problem, it could be a very routine problem, and so his accuracy would be very high, but then that does not guarantee the fact that the way he is solving a problem, how is he solving a problem, or what is the way in which he is solving a problem. Just with the fact that since he has seen problems like this, and so basically he solves it much faster or much accurate, does not give any sense of what the problem is or how the problem solving technique is. So, being accurate is just a chance factor, right, and so chance factor, accuracy has nothing or very less informative about the problem solving techniques. The other way to look into it is measuring solution times, which provides some useful information, but does not shed much light on the result of processing. Now, how quickly you solve a problem? Again, how quickly you solve a problem says how quickly you move from the initial state to the goal state, but it does not tell you whether you realize the hindrances, whether you got through the real hindrances. Maybe you are too lucky, and the fact that a number of hindrances does not arise. So, you have not considered all the hindrances, or you are lucky to get a set of rules which actually take you through the problem space. We will come to the idea of what a problem space is in the later section, but maybe that is the reason how you have solved the problem. And so, basically solution times are no guarantee to how the processing or what is the kind of processing which is happening. So, neither accuracy nor reaction time, which are the two major things in terms of behavioral research. Remember lecture 1 on methods of doing cognitive psychology, and one of the methods were the behavioral methods. In the behavioral methods, we were looking at something called speed accuracy trade off, or speed and accuracy as being two major ways of solving problems in cognitive psychology, or dealing with cognitive psychology related problems. And so, both accuracy and reaction time does not give you too much information about the solution process of how does it happen. So, basically then there are other ways of also how problem solving should happen. So, these are the two ways of solving a problem, but it does not tell you how the problem solution really happens. And so, solution of problems, of how people actually went and solve a problem, it is really a difficult thing to assess. And so, one of the ways to basically one of the methods which I used to basically come up with the solution was called the idea of a verbal protocol. But even before we go there, I have a problem for you, and let us see how do you solve it. So, this problem says that look at this problem, and I will give you a minute to actually read that and then basically come up with an answer. So, read this problem and let us see if you can answer it. I will give you half a second to read this problem, maybe 1 second to read this, 1 minute to read this problem and come up with an answer. So, starting now, here is your 30-second period for reading the problem and coming up with an answer. So, the 30-second period is up, and I am pretty sure that most of you would have been able to solve this problem. Now, this is a famous problem by Griggs and McGarry, and it was published in Journal of Experimental Psychology at some point of time. Do you know the answer to this problem? The answer is no. And so, those of you, congratulations, who could have solved this problem, and those of you could not, there is a way, there is no way that this is possible, this kind of arrangement is possible. And so, they also found, Geek and McGarry also found that only 50% of the people could solve the problem and 50% could not, if it is rushed through time. But given enough time, most people were able to solve it. The answer is no, it cannot be done. And so, this is basically the idea of how problem. So, basically in terms of reaction time, that reaction time does not say how problem is represented, because I really do not know how did you represent this problem. And so, maybe you have seen a problem like this before, and so you come up with an answer, and the accuracy of it also does not know how you solve this problem, because I do not know how did you make the representations of it. So, basically then what is the way in which I can understand how a problem is represented, or what is the process of representing a problem, or how did people solve a particular problem. And one important way through which we can do this is something called the verbal protocol. So, what is the verbal protocol? Now, in order to understand the process of problem solving, researchers make extensive use of something called verbal protocol. If you remember structuralism, there was something called insight, and insight is much a close brother to verbal protocol. And in insight studies, what was done is people were asked to do certain kind of psychological tasks, and then they were when they were doing this task, they were asked to basically relate how the task was being done, and this insight generation was something like this. Verbal protocol is a similar procedure in which people are to report how they generated the solution to a problem. So, which are reports? So, basically what are verbal protocols? These are reports generated by problem solvers as they think aloud during the solution process. So, as you are solving a process or solving a problem, people are made to go ahead and report loudly how they are solving it. For example, the problem of how do you add 2 plus 2, right? Now, how do you go about it? What is the way of addition? And so, what you could do is, first I think about 2, then I think about something called addition. Addition is basically this, then I take the other 2, I use the operator addition, I go ahead and add this, now I come up with an answer, now I verify this. So, this is basically how a verbal protocol really works in. So, all the steps that you take in doing addition of 2 plus 2 or any other problem solution, what you have to do is you have to tell in a stepwise manner what is going on, or what is the process that you are using. And so, this is what is verbal protocol. Do you see a problem here? I see. And so, what is the problem here? There are several problems with this kind of a protocol, and the first problem is that everyone does not have the verbal ability required to effect accurately what they are thinking. It is very difficult to verbalize what people are thinking, and so the problem here is that the ability of people to basically narrate what they are thinking is a major concern here. People are not able to narrate what they are thinking, and so verbal protocols fail, or the idea of loudly speaking out, thinking aloud what they are doing fails, because people do not have the verbal ability. They cannot generate, or they do not have the right verbal device or right verbal requirements or enough words to speak out the problem. The second problem is there is no way to assess the accuracy of what the verbal report is. Somebody may say something else and they may be doing something else, and so there is no way to tell if people are lying or cheating, or deliberately or undeliberately, indeliberately, if they are coming up with problems, or if they are reporting the right technique of how they are solving the problem. And so, there is no way of accuracy testing. And the third is that the very act of thinking aloud, it may interfere with or change the way a problem solution is thought. And so, since I am doing a dual task, right, I am also going ahead and loudly shadowing the process of problem solution, which is basically loudly also speaking it back. So, it is a dual task, and so this dual task may, the nature of the task itself, the idea that I have to use also verbal memory or verbal information processing, verbal representations, or basically repeat this thing back, may create problems, because what will happen is this idea of verbally repeating things back may interfere with the very idea of the solution, with the very idea of how the thought process of solution really works. And so, these are the problem with the verbal protocols, of course. So, these are the problems with the solution of problem. Now, another problem or another way why problem solution cannot be tacked onto, or it's difficult to look at how problems are solved, is because problems are of varied nature, and so the complexity of the problem solving presents another challenge for researchers. The fact that there are different kind of problems. There are devised set of circumstances, and from solving a math problem to solving a verbal problem to solving a traffic problem to solving any different problems. And so, with these such circumstances, there are a number of problems that may arise, and so all these problems may have different solutions. And so, that could be one of the factor or determining factor why problem solution or looking at problem solution could be a problem in itself. Now, Mann 1992, he distinguished 5 different types of problem that can arise, and so we look into these problems one by one, and then we look into the act of the problem itself. The first kind of problem that Mann in 1992 defined is called the transformational problem. And so, what is the transformational problem? It is a problem in which the solver is presented with a goal state, and he knows the initial state, and then what he has to do is to find out appropriate strategies to use those strategies and reach the goal state. So, you know the initial state, you know the goal states, and you have to do something or use the appropriate problem solving technique, problem solving strategies, and eventually reach the goal state. So, these are transformational problems. You have to transform from the initial state to the goal state using certain rules, by navigating certain hindrances, arrive at that. The second type of problem are called the arrangement problems. So, what are these problems? These problems present the user with all the necessary elements which are required for solving the problem. What is the role of the receiver then, the solver of the problem? He has to then arrange all these elements together in a way that gives the final solution. So, you know you are given all the solution elements, or you are giving all the parts of how to solve a particular problem. The only job of a person here is to basically arrange them, rearrange everything, so that the solution comes out of it. The third type of problem which arise here, or which people always face, or which Marr defined in his problem solving or types of problem definition, is called the induction problem. And what is the induction problem? Involves giving the solver a series of exemplars or instances. So, is basically forming an analogy and solving problem by analogy. So, induction problem, a number of instances or exemplars are given to you, and using this you have to figure out the pattern or rule that relates the instances together. So, you have a number of exemplars, number of instances are given to you, and now you have to find the pattern through which these instances are connected, and once you know these rules, once you form or you understand this rule, you will be able to find the final solution. So, induction problem, certain things are given to you, certain kind of exemplars or instances are given to you, you have to find the rule of how they are connected, and this rule will actually give you the final solution of how to reach from the initial state to the final state. In deduction problem, what happens is certain premises or conditions are presented to people, and they need to determine whether a conclusion fits the premises. So, certain kind of premises, certain kind of truth statements are given to people to start with, and then what people need to do is to they have the conclusion in front of them, and they have to look at the fact that given the fact that the premises are true, the conclusions are also true. So, this kind of deduction problem we will see in the next section, which is called thinking and reasoning. So, in terms of reasoning and judgment and decision making, the next section that we are thinking, we will see these kind of problems. Basically, these kind of deduction problems or this kind of premise related problems are syllogistic reasoning and the inductive reasoning, and so we will look at that in the next section. But for now, what deduction problem does is certain number of truth values, certain number of truth statements are given to you, and what people need to do is to find out that given the fact that certain truth statements are out there, whether the conclusion fits these truth statements or whether the conclusion fits the premises in certain way. And the last kind of problem which are there are called the divergent problems. So, what are these problems? They operate as in a way that the solver here has to give a number of solution, whatever comes to your mind, a number of solution, and so that is how the problem solution really works, or this kind of problem really works. So, divergent problems are those problems where a number of solution exists and the solver can then give you a number of solutions. So, let us look at these problems one by one. The first kind of problem So, 5 different problems. The first kind of problem that we want to look at is arrangement problem. Look at these words here. Can you rearrange the letters to form an answer? The answer here is VIKING. Very good for those of you who could answer it. So, this is an arrangement problem. Everything is given to you here. What you need to do is rearrange the letters so that you get the answer. Now, divergent problem, as I said, it lets the solver give a number of solution, and so as you think the problem here could be, think as many use of bricks. So, bricks could be used for beating someone, it could be used for making a house, bricks can be used for as a weight, as a substitute for weight, it could be used as a paper weight, it could be used for in selling something as a, in terms of standard weights, or so many other things, right. And so, these are divergent problems. This is a deduction problem. So, certain premises are there, and these premises. So, all professors are carrying people. This is a premise and this is true. The second premise are all carrying people are good. This is again a premise which is true, and so now you have to validate this conclusion which is drawn from these two premises. The fact that would you accept the statement that all professors are good, whether all professors are good follow from these two statements, and these kind of problems are called the deduction problems, right. So, certain premises are given to you and a conclusion has to be validated against the premise. The fourth kind of problem is called the transformational problem, and so what is here? In transformational problem, you have the initial state and the goal state known to you, and you have to use a particular strategy to arrive from the initial state to the goal state. And so, as you see, this is called the Tower of Hanoi problem, and so you have to, the fact here, the requirement here is to move these three circles from position A to position C. So, same arrangement here. The only thing is you can make you can move on these circles one at a time. So, one movement is allowed, you can move from here to here or here to here kind of a thing, right. Also, the fact that a smaller circle will never go beneath down on a, or a smaller circle cannot be beneath a larger circle. So, that is the kind of thing. So, how do you arrange from here to here, and so you are this is the initial state, this is the final state, and so by moving one at a time, and this constraint, using this constraint that a smaller circle cannot be beneath or cannot be below a larger circle, you can solve this problem. This is called the transformational problem. And the last kind of problem is called the induction problem, and this is look at the number in your sequence and then come up with a solution. So, this I will explain to you. This is rather interesting. So, take your time, solve this problem. I will give you the solution to this problem, but let us wait for it, and because I will use this problem at some other places also. So, can you find out a rule through which these numbers are connected? There is a rule, remember. So, if you go about 5 minus 4 is 3 or 8 minus 5 is 3, 5 minus 4 is 1, 4 minus 1 is 3, you will never come to the solution, because there is a certain rule to it. I will tell you the rule, but that will happen as we progress into this section. So, how do I solve a problem? What are the various approaches to solving a problem? There are several approaches to solving a problem. For example, the first approach is behaviorism, solving problem as associative learning. So, two approaches I will describe here. One is the Gestalt approach, the other is the behavioral approach. Comes from the first section itself, Introduction to Cognitive Psychology, where we saw what is behaviorism. Behaviorism is basically understanding stimulus response relations. So, basically what behaviorist said is there is nothing called the cognitive system, there is nothing called the human mind. There is a behavior, there is a response, and making connection between these behavioral response or behavior and response is what behaviorism is all about. So, look at each behavior, look at each response, find the most optimal response. The most optimal response is the correct response to the stimulus, and this is associative learning, associating a response to a stimulus. So, behaviorism presents a solution to problem solving or gives a way to solve problems. And so, the people who started explaining problem solving as behaviorists, as behaviorism, were early behaviorists like E.L. Thorndike. And so, Thorndike 1800 he conducted his first systematic study of problem solving using cats. So, what he did was he was looking at feline animals, and so he took this feline animal, put it into some kind of a box, a capture box, and so cats doesn't like to be captivated into box. So, what he did was he took this cat, put it into a box and enclosed the box. Within the box was a lever. the cat had to realize to press this lever. Now, look at the easiness of it. What cats do when you enclose it into some kind of a structure or in some kind of a cage, it tries to scratch it, and so this lever was placed in such a way that it needs to be scratched down or bent down from the paw, and so the scratching ability would give the cat the idea to scratch this or bend this paw, and so later sooner or later the cat will realize that if I scratch here, so where the lever is, so this is my box, and so the cat is put here, right, and so here is the lever. The cat initially goes ahead and scratches everywhere, right, but once it scratches here, there is a door which opens and the cat can now escape out of it. So, the cat has to realize that this is what, and this is the solution to the problem. So, Thorndike was interested in knowing whether the ability to solve the confinement problem would appear suddenly as an insight or gradually through the process of trial and learning. So, what he wanted to see is that whether cat did something for learning this solution, that if I scratch the right button, a door will open and I will get out of it, or whether the cat sits and through insight, through some kind of magic or through some kind of internal problem solution, will the cat be able to know that I scratch this. And so, what they found out, that the cat learned the idea that if I press this button, the door will open and I can move out of it through something called trial and error. And what is trial and error? What the cat did was, it scratched everywhere, and so if it scratched a number of times, slowly it realized that if I scratch at this button, what is going to happen is the door is going to open and I am going to come back of it, and so that is what he realized. Now, Thorndike described the learning process with which is termed as something called the law of effect. And so, what is law of effect? It states that if a response leads to a satisfying outcome, the connection between the response and the situation will be strengthened, but if it leads to not satisfying outcome, this is deleted. So, scratching was a satisfying outcome. Scratching on levers, scratching on things which was coming out of the cage was a successful response. So, the cat scratched on everything which was protruding out of the cage, but then it started not scratching on polished surfaces, right. So, this idea of scratching onto those objects which are protruding out or protruding in, or which was shiny in Thorndike's case, lead to the freedom of the cat. That is, this association, increase in association with this fact that I should scratch on those objects which are shiny, or those objects which are illuminated in some way, or which looks like a lever, will actually make me escape, is what is called the law of effect. And so, what law of effect says that the cats learn that when I do a certain act, and if I am positively rewarded, I will do this, if I am not positively rewarded, those acts I will not do. And so, this is what the Thorndike box is all about, and what you can see here is the number of trials that the cat took and the number of time required to escape, and as you see, initially it is very high. So, this is trial and error, and so as the cat kept on doing it, later on the time required was in terms of 100 seconds, right. In the by the 17th trial, the cat was as fast as you put into it, within 100 seconds it will escape, but initially it was requiring 600 seconds to find this idea. And so, if you can see, this is where the cat is, this is what the arrangement is all about, and here you see the latches, and so it needs to scratch. If it scratched on the right surface, the door will open, and that is what it was it. And so, what behaviorist said is that the solution to problem is always in terms of trial and error. In opposition to the Gestaltists, which believe that by forming perfect associations between responses and stimuluses can a problem be solved. So, problem solution is basically making up new associations and rewarding those associations which give us reward, or learning those associations which give us reward. Gestaltists oppose this view. They said that problem solving is basically an insight related process, which basically means that it is not the act of doing something which solves a problem. Problem solving happens because people restructure representations, people restructure the problem in certain way, meaningful representations, and these restructuring of meaningful representation is how the solution is generated. So, Gestalt psychologists, they believe that mind has an inherent tendency to organize incoming information. So, what the mind could do, and we saw in Gestalt theory, what Gestaltists propose is certain Gestaltist law. And what does this Gestalt law really say? It says that the mind organizes stuff, restructures information, restructures mental representations, and this is this restructuring which gives solutions, which makes easy solutions, right. So, what the mind does is it always organizes and restructures information, right. Now, defining features of condition. Thus, rather the defining problem solution as mindless playing out of associations that gradually build up over time, they believe that it involves restructuring or reorganizing the problem. So, they believe that solution to problem does not come from trying again and again, making associations, mindless associations between the fact that sometime I will get rewarded, or at some point of time I will get rewarded, or some of my behavior will get rewarded. They said it is not the solution. The solution is, the solution to problem comes from the fact that when I look at a problem, and not only look at a problem, I restructure it in certain way, I rearrange the problem elements in certain way, so that the answer comes to it. That is what a solution to a problem is all about. Now, a pioneer to this study, or pioneer to Gestaltist school was Wolfgang Kohler, and so what he did was he found a popular way of basically, or he found a way to test this idea that insight leads to problem solution. So, basically for Gestalt psychologists, then problem solution involves a process of restructuring whereby problem elements are suddenly recognized and seen in a new way. So, what happens is they believe that the elements of a problem, the problem itself is restructured into a mind, and it is kept on restructuring till the point of time that a solution suddenly appears to you, and this is called an insight, or in some books it will be called as the aha experience. So, this aha experience leads so what happens is that problem solution has a stage where people do not do anything, they just sit passively and reorganize the problem, or rotate the problem in certain way, mentally restructure the problem in certain way till a solution happens. So, against the fact that what behaviorists said that problem solution is all about making or doing acts and learning a solution, what they believe is it is mental restructuring which leads to reorganizing of information, which leads to problem solution. So, the sudden successful restructuring of a problem element is termed the insight, and this is the major focus of Gestalt approach. And so, how they tested it? They kept certain monkeys and with crates, and then an appealing item. So, this is what an appealing item is. Here is the appealing item. Here some banana were actually taken in and they were hinged onto the roof, and certain crates were given to these monkeys and they were made to sit. What Kohler found out is that initially the monkeys try to jump to the roof and take the banana. Now, that was not happening, because no matter how hard the monkey jumped, they were not able to reach the roof. So, what did they do? They kept trying everything, right. Initially they kept trying everything, and then after a period of time they sat there with the idea. Now, the solution is right there in front of it. There are number of crates which can be put over one another, and a kind of a ladder can be generated. So, what these monkeys did was they sat there for a certain period of time, and then later on, after a certain period of time has elapsed, suddenly the idea came to them, or they developed this idea by restructuring this problem, and so they stacked the boxes in this way, and now it is like a ladder, and so he climbed on the ladder and takes the food. So, this wait time is what is called the insight, or this wait time is what leads to the insight and the solution to the particular problem out there. Now, cognitive psychology could also suggest, or does also suggest solution to problems. So, cognitive psychology also is a way of solving problem, and what is the suggestion here? Now, just as computer solves a problem by executing programs that use certain information stored onto it, humans also solve problem by applying certain mental process to representation. So, what does computer do? Computer program takes in information in certain way, arranges this information in a certain way, does certain kind of processing or manipulations, and come up with a solution. Similarly, what earlier cognitive psychologists like Neville, he suggested that humans also solve problem in this way. The problem solution happens by applying certain processes, applying certain rules, or applying certain methodologies to already stored representations. So, already stored representations which are coming from perception, attention, and so on and so forth, the basic processes, these representations are basically taken in and certain processes are applied onto it, and these processes lead to finding the solution to a problem. So, basically they gave these early cognitive psychologists gave the idea of something called the general problem solver. So, what is general problem solver? The general problem solver is a conceptualization of the computer program which solves a problem. And so, what does the general problem solver does? It takes in a problem, breaks it into sub problems, and then by solving this sub problem one by one attains the final goal state. And so, this is what the general problem solver does. And so, this is what Newell also says. So, Newell and Simon in 1972, they originated the conceptualization of problem solving as a step by step process from an initial to the goal state. So, what I do here is, if I have a bigger problem, if I have a problem of writing a research paper, what I do is I break it into smaller problems, smaller sub goals, right. And so, each sub goal, I take the initial problem, divide it into certain parts, and then each part now has a goal and a sub goal. And then what I do is start from the first part, start initially from the first sub part, reach to the sub goal, then start to the second part sub goal. So, writing a paper could be first going to the library and sitting there, achieving that. Once I do that, then reading something in the library, then understanding something, then finding a new problem, then reading a little bit about that problem, then coming up with the answer of what the problem is, then discussing with certain professors or looking at certain materials into the internet, and finally writing the paper. So, the writing the paper is now broken down into several steps. And similarly, this is what Newell and Simon did. They said that larger problems can be broken down into smaller problems and can be solved by step process from the initial state to the final state. They did so within the framework of a computer program which is called the general problem solver, or the GPS. Now, what is the GPS? The GPS is basically a model of human computer problem solving. Human problem solving. Now, one that can be applied to any problem. So, basically it is equivalent to computer problem solution. So, basically the GPS is a model of human problem solving which is basically made, or which is basically developed out of the computer problem solving things. Now, this approach minimize the distance between the initial state and the goal state by breaking the problem down into a series of sub goals. So, what I do is, if a bigger problem is there, I know the initial state, I know the goal state, and I do not know how to solve it. I take the initial problem, I break it into its part. As I said, breaking the writing paper problem into its part. So, first I will go to the library first and achieve that thing. So, initial goal is starting from here, final goal is reaching the library. Once I reach the library, I will see so many people, I will got motivated. So, first problem solved in terms of motivation of writing it. Then I will read some books. The more I read books, the more ideas will develop, and when that happens, when I have a number of ideas with me, I will then consult some professor or some kind of a TV program or some kind of internet websites where more information is given, and from there I could write a problem. So, basically this whole writing a paper problem is now broken down into subparts, and this is what it is said here. In the GPS also, I minimize the distance with from the goal to back to the initial problem by creating sub problems or by creating sub goals, and it is easier for a person to reach from reach the goal through sub goals than to reach the goal on its own. Now, the sub goal analysis is accomplished through the application of something called operators. So, how do you reach the sub goal? There are certain operators. Now, what is operator is basically a fancy word which is out there for problem solving techniques. So, one solving technique is going to let us say the library, and that there is one thing into it, and then there is reading a book. So, how do you read a book? There is a certain technique of motivating yourself, and then there is another technique, and so on and so forth. So, basically these problem solving techniques, taking a bigger problem and solving it requires several techniques. A bigger problem could be how to find out how do people process first language, right. So, if people have dual language proficiency, let us say I have a proficiency of English and Hindi. Now, if something is spoken to me in English, how do I respond to this? Do I take this thing, take this word in English and search for solution to it in English, or do I take the problem, the word which is being spoken to me in English, translate back into Hindi, search for the solution in Hindi, then come up with a solution in English and then respond it back. Now, this is the problem. How do I break it into several problems? First is the behavioral part, second is the cognitive part, the third is the neurophysics part. So, first I will do some behavioral analysis to see how the solution is, and then another sub part is there. So, part of it looking at behavioral response. So, kind of design problems in terms of several problems could be developed in which a certain kind of sentence is given to you and answer is looked into. So, several kind of things is there, and we will look at the speed and accuracy of how you are doing it. Then we will design a cognitive experiment or maybe a brain related experiment, EEG ERP experiment, where we look at the time process or the brain potential, what happens in the brain when you are solving this problem. And by combining these two things together, these two sub problems, I can finally say how do people think or what is the way, because the behavioral will only give you the result. What happens in the brain you do not know. So, you use brain imaging techniques to tell you what happens in the brain when this kind of problem, dual language or single language people solve a problem. So, basically that is what it is, and so these using those two techniques is called using the operators. So, these techniques are applied at the micro level to reduce the differences between the current state and the sub goal state. So, what could happen is, since I have created a bigger goal, I mean from starting from the initial point to the final point is as the bigger the problem space, the bigger problem space, I now divide the problem space into sub problem space, and so the I can use operators both at the level of micro level, which means navigating from navigating within the sub problem in the earlier case that I defined. So, I can use certain operators or use certain techniques for studying only the behavioral part of it and the electrophysiological part of it. This is called the micro level analysis, and then to reduce the distance between the initial and the goal state, or I could use a bigger technique, which is techniques of summation of results, right, reduction technique or some other technique by through which I can take the two results that I have, the behavioral result and the electrophysiological result, match them together and get the final solution. So, I can use operators both at the micro level, where each part of the problem, how each part of the problem is solved or sub problem is solved, and then use techniques at the micro level of integrating these results together to give us the final solution of how do people who have two language proficiencies really think. So, GPS is a notion of problem space, which basically refers to the problem solver's mental representation of the initial state, the goal state and all possible intermediate sub goal states, and the operator that can be applied to these. So, basically GPS talks about a initial state, a goal state and sub problems and certain operators into it. So, look at this definition or look at this picture. This is how the solution will really look at. This is an idea of a human GPS, general problem system. So, as you look into it, this is the problem solver, this is the noticing or evoking mechanism, external environment, long term memory, immediate problem space, goals and constraints. This whole thing is called the GPS. Now, how does it really work? This is my GPS system. So, this is my initial state, and then I have so many inputs, these are operators onto it. This is my goal state. So, what I do is I break my problem into several parts. So, this is the behavioral part, this is the electrophysiological part, this is the cellular biology part or cellular biological mechanism part, where I look at certain cells of how they respond to certain neurotransmitters, which how they will work, and this may be another imaging. So, this is electrophysiology and this is brain imaging, and from all these I will combine the results together to come up with the solution of how people who are two language proficient think, or how do they come up with solutions. So, basically then this is what it is, this is how the idea of a general problem solver is really done. So, in this today's lecture, what we did was we talked about what is a problem first of all, definition of a problem, and we saw different definitions which are out there. Then we looked at a number of problems, a number of types of problems which exist out there, and we discussed these types one by one, and after that we looked at certain approaches to solutions of problems. We looked at the Gestalt approach, the cognitive approach as well as the behavioral approach, and we saw how what these approaches has to offer as solution to the problem. In the upcoming lecture, we will look into how a problem is actually solved, and then we look into something called creativity and insight of how do they go with problem solving. Thank you.